In this video, we're going to talk about physical properties of alcohols and what hydrogen bonding is and how it influences those properties. So alcohol molecules have both polar and nonpolar characteristics. The alcohol group is considered polar, where the alkyl group, or whatever the carbon-hydrogen chain is considered nonpolar. So the physical properties are going to depend on which part of the structure dominates. The length of the nonpolar carbon chain is usually the biggest indicator, as well as the number of alcohol groups present. So if the carbon chain is getting longer, it's going to resemble properties of hydrocarbons more than alcohols. As your number of alcohol groups increases, then it's going to act more like alcohol. If we look at the shapes of these structures, here's some space-filling models. The green portion for each of these is the nonpolar hydrocarbon portion, and the red is where the alcohol group is. So this kind of gives you a sense. The methanol almost kind of feels like it's half and half, whereas this octanol, a large portion of it is the hydrocarbon, which is nonpolar, versus the alcohol, which is polar. So methanol is soluble in water. It's polar enough that it will dissolve in polar water, but it is insoluble in hexane, which is nonpolar. Octanol, which is mostly hydrocarbon, is going to be insoluble in water and soluble in hexane, because the nonpolar part dominates. Boiling points of alcohols that have the OH group on the end are going to increase as the length of the carbon chain increases. If you've got small alcohol groups that are only one OH group present, these are always going to be soluble in water. And then as your carbon length increases, your solubility in water rapidly decreases. So here's an example of boiling points and solubilities as far as graph goes. So what we have across the x-axis is number of carbon atoms versus boiling point on the y. So notice that as the number of carbons get bigger, the boiling point also gets bigger. It's almost a linear trend. The second graph, we're looking again at number of carbon atoms versus solubility. So if we have 3 or less carbon atoms, your molecules are completely soluble in water. Once you get to 4 or more, your solubility very quickly decreases to where you're at 7 and it's almost essentially insoluble in water. So the differences in the physical properties between the alcohols and hydrocarbons or alkanes come from this hydrogen bonding. So alcohols are going to have a higher boiling point than alkanes, and alcohols have a higher solubility in water than alkanes. And again, the difference is hydrogen bonding. So what is hydrogen bonding? Hydrogen bonding is an interaction between the hydrogen of one molecule and the lone pair on an oxygen atom of a second molecule. This interaction, you can kind of think of the hydrogen as being partially positive and the electrons being partially negative. So you've got kind of a little magnet attraction going on. So here's an example of hydrogen bonding between water and an alcohol. Here's another hydrogen bond between water and alcohol. Here's another one down here. You can also have the alcohol hydrogen bond to itself. So anytime you have two molecules where one molecule has an oxygen and the other molecule has a hydrogen attached to an oxygen, you will have this hydrogen bonding. Now it's not actually a bond. Okay, we're not sharing electrons, but it's an interaction between a positive end and a negative end. By doing this, these molecules are going to stick together more, which will increase their boiling point. So remember, boiling point is trying to pull these molecules away from each other. And if they're stuck together, it's going to take more energy to pull them apart and therefore have a higher boiling point. Solubility is affected because the alcohol and the water molecules want to interact with each other, so they will dissolve in each other. So here's a practice question. Which member of each of the following pairs would have the highest solubility in water? So if we're going to compare one pentanol to one butanol, the difference is pent versus but. So the smaller molecule is going to have the higher solubility. The second example, we have a triol versus just one alcohol group. The more alcohol groups you have, the higher the solubility. For the second set here, we want to pick the one that's going to have the higher boiling point. So first we're comparing but to hept, and your larger molecule is going to have the higher boiling point. Then we're comparing a single alcohol group to a diol, and the diol is going to have the higher boiling point.